Okay, this is the P3 paper from June 2023. This is question number 1, which is a numerical methods question. In particular, it's locating roots followed by fixed point iteration. Let's have a look and make a start. So it says, show that gx has a root alpha in the interval 3 to 4. So you should know how to do that. Let's make sure we get all our language correct when we're looking at this question. So first thing to do is to say gx is equal to x to the 6 plus 2x minus 100. And what we're going to do, sub in 3 and see what we get. 3 to the 6 plus 2 lots of 3 minus 100. That works out to be minus 265. Sub in 4 and again see what we get, which this time is 4 to the 6 plus 2 lots of 4 minus 100, and that works out to be 3,104. And the key there is that we've got a sign change. If you've got a sign change, then there's a root. But get the language correct. So we're going to say, since there is a sign change, that's not enough to get the mark, since there is a sign change. And we also say fx is continuous in the interval, and fx is continuous in the interval. Therefore, there is a root. That's enough information to get the marks. The examiners are looking for sign change and they're looking for continuous. So make sure you've got both of those. I just used exactly the same language as I've done there. I use it every single time. On for part B. Use the iterative formula here. We're starting off with x1 equals 3. First of all, we're just going to find the value of x2 and make sure you do it to 4 decimal places. And then secondly, they said give your answer alpha to 4 decimal places. What you're going to do is, what they say, just keep repeating the iteration up to the point where, how many decimal places? To 4 decimal places, your answer isn't changing. And once you've done that, then we know that we've got that right. So part B, we said the iterative formula is x to the n plus 1 is equal to 6th root of 1,000 minus 2x to the n. And what I always do with these personally is I say that x1 is equal to 3, show x1 working, or rather find x2 by subbing x1 in, but this is the only time that I'll do this. So 1,000 minus 2 lots of 3, and then when I get my answer out here, and I'm only doing it to 4 decimal places, so 3.15, well that's 91 to 4 decimal places. When I find x3 and x4 and x5 and I keep going there, I'm not going to show any working out for that at all because there's no marks for method now. I've shown the method. So x3, I worked out to be 3. I know I'll write the whole numbers down, but 158938868. Make use of the answer function on your calculator or find a quick method of doing all these guys. Not as quickly as me, obviously, I've done it. I'm just writing down what I did each time. 3.1589 and then 39047. Now, it's just a matter of how many steps you want to go to till you see that to 4 decimal places in this case. I could almost stop here, couldn't I? Because look, it's 3.8, then it's 3.9. I just want to make sure that doesn't... let's do the next one, 3.1589, and then it was 39046. Look where this is changing now. This is changing all the way down there, so I'm more than happy to at this stage say that to 4 decimal places it's 3.1589, or alpha, I think it was what they actually wanted there. So it's time that it takes you to do these questions versus just making sure you get all the marks for that. A relatively straightforward first question, hopefully. Okay, hope that all makes sense.